Hello guys, this video is for pre-cal week 8, Monday and Tuesday. We're starting a new chapter, which is 7.1 on sequences. Okay, so you guys kind of learned this before from Algebra 2, but in pre-cal the questions would be a little bit more difficult. Okay, so let's talk about what a sequence is first. A sequence is an ordered list of numbers. So whenever you're, given just numbers like these three numbers, even though they don't look like they have anything in common, this is still considered a sequence. Okay, just the definition itself, you don't have to have a specific pattern to it. Okay, and then now we're gonna get into finite sequence and infinite sequence. Okay, so finite sequence is what we just wrote up here. But when we talk about infinite sequence, it can still be this, but with a dot 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 in the back. Okay, and these three dots, we kind of call it three dots, indicate that the sequence continues without end. Okay, and now we're going to get into two types of sequences. One type is called the arithmetic sequence. Okay, so the arithmetic sequence, there's one way, really easy to figure out whether it's arithmetic or is the other way geometric or is it neither. So for arithmetic, the pattern is adding exactly the same amount. Okay, so let's give some example. We have 1, 3, 5, 7. You can tell that these numbers we are adding by 2. Okay, and then we can also have -1, -2, -3, -4. Oops, I forgot my dot dot dot. Let's see, this is a sequence that goes on forever. So for this side, our pattern is subtracting 1, right? But whenever we're talking about arithmetic sequence, it's better to say that we're adding a -1. Adding a -1 for each of these. Okay, and it's pretty easy to continue to find, the next number and the following number because you kind of already see what the pattern is. So let's give another example. Now, if I say 10, 15, 20, 25, dot, 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 and I say find the fifth and sixth term, how do we do that? We look at our pattern. This is adding by 5. Okay, so that means my answer right here would be, if I add 5 to 25, it would be 30 and 35, right? That's pretty easy to do. But what if I say find the 100th term? You're like, oh, okay, I'm not going to keep adding all the numbers. So there's an explicit formula, which make sure you write this one down. Explicit formula, that means I want to find a formula that I can put in like 100 or 200 or any of those, and it will just give me the answer right away. Okay, and this formula is a sub n, meaning the result that I want, equals, we first have to get the first term, which we call it b. And since we're adding to get to the next number, we're going to be adding d, which is the difference or the pattern, times n minus 1. Okay, again, this one is basically the result, and b is the first term. So if you're given the first term, that's where it goes. And d is the pattern or the difference. Okay, and last one, n is the number of terms. So in our case, if I have to substitute in everything to get the formula first, it would be a sub n equals to 10, because that's my first number, plus pattern is 5 times n minus 1. So this is our formula, and I'm going to be substituting in 100 for n to figure out what it is when it's the 100th term. Okay, and this together gives me 99 times 5 plus 10. 10 plus 495 would be 505. Okay, so you have to know what the formula is in order for you to figure out a number that's really big. Okay, so I am gonna go into the next thing, which is geometric sequence. Okay, so the first one was arithmetic, the second one is geometric sequence. And again, the pattern is multiplying exactly the same amount. So this one is like exponential. Let's give out some example. We have 1, 3, 9, 27, and dot dot dot. What's our pattern here? This looks like we're adding by 2, but the next number we're not adding by 2. So we have to think about multiplication, which is multiplying by 3. And the next number, we multiply by 3 to get to the next number. And same thing. Okay, so question-wise, if I ask you to find the 5th and 6th term, you can just multiply by 3 to get to the next one, which is 81. Okay, because 27 times 3 is 81. And now I'm going to take my 81 times 3, which gives me 243. Okay, so these would have been the next two numbers. And if you're going to keep going, you're going to keep multiplying by 3. But if you don't have a calculator, actually, no, this one you kind of need calculator too. But if they're asking for like the 10th term, yes, you can actually, do times 3 and keep going to get to that. But if the number is bigger, you would need a formula, which I'm going to write the formula right here too. So the explicit formula for geometric sequence is g of n, or g sub n. The other one was a sub n because it's arithmetic. This one is geometric, so it's g sub n equals to b, which is our first term. And now since we're multiplying, we're going to be multiplying r to the n minus 1. Okay, again, g sub n is the result. B is your first term. R. Last one was D. This one is R because it's still the pattern, but R stands for ratio. And N is the number of term. Okay. So some of you guys wonder, why is it -1? Because right here, we are looking at the first term already. Like we're given the first term. So do we even need the R at all? No, right? Because this first number, I don't need to multiply by 3. I can just keep it as it is. And then the next number, I would have to multiply by 3. And then up here, it will start making a 1 because it's 2 minus 1. Does that make sense? Like, because it's a second number that we're going to be figuring it out. So 2 minus 1 will be 1. And then that's how you can multiply your B and R together. Okay, so let's go back to our formula. I'm going to go G sub n equals to our first term, which is 1, times pattern, which is R, and, which is 3, to the n minus 1. Okay, as you can kind of tell, times 1, it can kind of go away already. Okay, but I'm going to put 10 here equals to 1 times 3 to the 10 minus 1. 3 to the 9th power, which is 59,049. That's how you figure out your geometric sequence. Okay, I'll show some more examples and then we'll get into our homework. So next example, if I give you 6, 12, 24, 48, can you write your explicit formula? Okay, it would be G sub n equals to 6 times, pattern is 2 to the n minus 1. Okay, keep in mind we cannot multiply our 6 and 2 together because the 2 has exponents. Whatever it is, you got to figure out what the exponent is, perform the exponents, and then we multiply by the 6. Okay, so our B in this case is 6 and our R in this case is 2. That's how we got the answer. Okay, let's do some word problems. Let's look at find the 9th term of geometric sequence, and you're given the 4th term is 4 and the 7th term is 5. Okay, so let's see how we figure this one out. If I know my 4th term is 4 and my 7th term is 5, and this is a geometric sequence, I don't know how much I'm going to multiply to 4 to get to 5 in like a few numbers. Okay, so we have to use a formula, which is G sub n equals to G sub 1 times R to the n minus 1. Okay, but we're going to be using this formula a little bit differently because we're not given a first term. So instead of saying we're using our first term, we're going to be using our 4th term right here. Our 4th term is 4 from here. Okay, and we don't know our pattern, so pattern is remain as R. And our result right now is actually 5 right here. Okay, how many numbers is the fourth and the seventh term apart? It's 3 numbers apart, right? So it's 7 minus 4. 7 minus 4 is from these two numbers. Okay, and then this, with us plugging everything in, we're going to be solving for the ratio first. So we're going to divide by 4, which we get 5 over 4 equals to r to the third power. Multiply both sides, or raise it to the power of 1/3. So these can go away. So I know my r equals to 5 over 4 to the 1/3. Okay, this is one of those challenging questions. And I think this is question number 35 from the exercise problems. Okay, and then last step, we got to figure out the ninth term. So if I say g of ninth equal to our seventh term, so I'm going to write it in a formula form first. If I want I know my seventh term, and I'm going to multiply by r, what power should I raise this to? How far is the 7 to the 9? It's only 2 numbers away from each other, right? And now I'm going to substitute in my numbers. G sub 7, it's a 5, times our ratio, which is 5 over 4, raise it to 1/3. And we're going to raise it to the second power. This is going to give us the G sub 9. Okay? This together is going to be 2/3. That is 5 4 times 5. If you put this in the calculator, it's approximately 5.80. And that's how you do number 35. Okay, so I want to show you some of this is definitely the hardest one out of all of them. And I will do number 36 for you, so just hang on. And let me just do number 37 as well. I think it's 37, yeah. So you can see how to do number 38. So number 37, it's find the 100th term of geometric sequence given the 10th term and the 11th term. So they tell you that the 10th term is 5 and the 11th term is 8. Okay, if you think you got the hang of it, go ahead and do this on your own and check back the answers with me. So I have G sub n. Remember, G sub n equals to G sub 1 times r to the n minus 1, right? This is supposed to be the formula, but since we are not given the first term, we're going to tweak this formula a little bit. Instead of doing the first, we're going to actually have the 11th term, and we're going to put the 10th term here, times r. And since we know our 10th to 11th is only one number away, it is just 1. Okay, substituting our number, we got 5 times r, raise it to the first power, which is just r, equals to 8. That means that r in this case would be 8 over 5. Okay, we got our r ready to go, and we're going to substitute it back in to find the 100th term. Okay, so G sub 100, and the closest to 100th term that we know is just the 11th term, right? So I'm going to be substituting G sub 11 times R to the How far is 11 to 100? We write it up here. Okay, I think it's 89. So let's substitute whatever we know. G sub 100 is what we want to find. G sub 11 is 8 times 8 over 5, that's a R, to the 89th power. And then you can actually put all of this in the calculator. Your G sub 100 is going to be about 1.2 times 10 to the 19. Okay, the reason why I put it in decimal format is because this is one of the calculator questions. And this one too, calculator question. Okie dokie. So I'm going to go ahead and do some of your homework questions for you. So hopefully you can get the hang of it. These are, I'm going to be doing these 6 and these 2 as well. Your homework, let me show you real quick. This is the homework page. The left side is Monday's homework. The right side is Tuesday's homework. You're only going to be doing the odd ones. Even ones. And this section, and this section, all 3 of them are given kind of the same instructions. So I kind of took 2 questions out of each of them and put them right here. So this is part 1 and this is part 2, or A and B. It says, find the sequence using the 3-dot notation giving the first 4 terms. And then part 2, it says, give the 100th term of the sequence. Okay, so number 5 and number 8, they already gave us the explicit formula. So I can just go ahead and put, starting with 1, put 1 into the end. So it'll look like this. 1, let's zoom into this. So 1 over 1 plus 1. That's the first term. 1 over 2 plus 1. And then see what the answers are going to be generating. We get 1 over 2. The next one is 1 over 3. You can keep writing the formula, but I know the next one is going to be 1 over 4 and 1 over 5. Right? So this is part A's answer. Part B, we got to plug in 100 now. So just to make sure I'm doing this correctly, I'm going to be, oops, sorry, I forgot my square roots. Square root, square root, square root, square roots. This one too. Square roots of 1 over 100 plus 1, which gives us 1 over 101. That's our answer. And these are your answers too. Okay, so if they give us the explicit formula, it's actually pretty easy from there. Let's look at number 8. Number 8 is your homework question. So I'm going to look at part A. 1 minus 1 over 3 to the first power. 1 minus 1 over 3 to the second power. 1 minus 3 to the third power. And 1 minus 1 over to the 3 to the fourth power. Okay, so 1 minus 1 over third. That means if my 1 becomes 3 over 3, my answer would be 2/3. Okay, this is going to go away, become a 9. And if this becomes 9 over 9, and I subtract across, we get 8 over 9. Okay, so you kind of see a pattern right here. The denominator is just 3 to the whatever power they're asking. And the top number is just 1 number less. So the next one, if I know this is going to be 9 times 3 is 27. So my answer is 27 at the bottom, but the top is going to be 26 because it's 1 number less. Okay, 3 to the fourth power is 81. So it'll be 80 over 81. Okay, part B, it's 1 minus 1 over 3 to the 100th power, right? If you put if you put 3 to the 100th power, your calculator is going to overflow and you're not going to get anything. So in this case, we're actually just going to leave this as the answer. Some of the answers that are way too big, don't worry about solving for it. Just leave it as it is. Okay, so these are your answers for part A and part B. Let's keep going to number 9 and 14. So look at these. They all start with B, but then 2 of them says D and 2 of them says R. And if you remember, D is the difference, which is the arithmetic. Okay, same as this question. These are arithmetic. And this one right here is geometric. So let's write down our formula first. Our formula for number 9 is a sub n equals to a sub 1 plus d times n minus 1. Same thing. This just helps us to substitute in the answer. Okay, so this is going to be a sub n equals to 2 plus d times n minus 1. That's the formula. And the other one is a sub n equals to negative 1 plus 3 over 2 n minus 1. That's our other formula. Okay, sometimes the question itself doesn't require the formula to do it. We can just write the answers out. So part A, our answer, we want the first 4 numbers, right? I know the first number is already 2 because that's the first term. And then if it says we're going to keep adding 5, that means my next number is going to be 7. Add another 5 will be 12. Add another 5 will be 17. So this first part should be easy. But second part, because we're going to be finding the 100th term, it's easier if we substitute it into the formula. So it'll be 2 plus 5, and we're going to put 100 minus 1. And if you put that in your calculator, you should have gotten 497. That's the answer when you put in 100. Okay. Let's keep going. I'm going to split this up. Okay, so the next question is we already have the formula. Our first term is negative 1. And if my negative 1, we're going to be adding 3/2 to it, it's going to be 1/2. Okay? Add another 3/2 to it is going to be 4 over 2, which is really going to be 2. Okay? Add another 3/2 to it, this is going to be 7 over 2. So if you want to, you can leave your answer like this. And then for part B, we're going to substitute in, I want 100th term, so I'm going to put 100 minus 1. Okay, you would get 295 over 2. So these are your answers, and this is your answer as well. Okay, bottom one, it's multiplication. So let's figure out the formula. Formula is going to be g sub n equals to g sub 1 times r to the n minus 1. G sub n equals to g sub 1 times r to the n minus 1. Okay, so we got 1, because that's our first term, times r, it tells me that is 5, to the n minus 1 equals to g sub n. Okay, that's the formula. And over here, the formula would be g sub n equals to 4 times negative 5 in parentheses, and then n minus 1. Okay? And then our part A and part B. part A, the first term is 1. Second term, we gotta multiply by 5, which is we get 5. Multiply another 5, we get 25. Multiply another 5, we get 125. And dot dot dot. Okay, over here to the right side, 4 is my first term. This is right here. And then the next term, we gotta multiply by -5, which we get -20. Multiply another -5, we get 100. Multiply another -5 is -500. If you can see, the numbers alternate with the signs. One's positive, positive, and negative. Okay. Part B, we're gonna start substituting our 100 in here. Okay, so this is going to turn out to be 5 to the 99th power. This is so going to overflow your calculator, so just leave it as 5 to the 99. Okay, this one also, I'm going to be putting in 100 equals to 4 times -5 to the 100 minus 1. 4 times can stay, and then -5 to the 99th power. Okay, you can leave your answer as like this, or we know that negative, if it's raised to an odd number, the negative is still gonna remain. So it's gonna be, you can write it as this way as well. Okay, either way works. Either this one or this one. Okay, and these are still my first 4 numbers. Okay, so I'm gonna do 2 more questions. Two word problems, and one of them is an odd number, but it's really similar to one of your homework questions. Okay, it says find the first term of the arithmetic sequence whose second term is 19 and whose fourth term is 25. So I know a sub 2 is 19, a sub 4 is 25. And since this is arithmetic, you can use the formula or you can kind of use your common sense. Where like arithmetic, we're adding number. So how many numbers does it add from 19 to get to 25? That's adding 6 number, right? But we are skipping a A3 in the middle. So if I have a number right in the middle, that means how much does each of these number add? We add 3 for each of these, right? So total is 9. So that means my third number is going to be, the middle number would be 22, because I add 3 to get to that. But our question is, find the first term. So I gotta go backward. If I gotta go backward, from this number I add 3 to get to 19. That means this number right here would be 16. Okay, so think about it. 16, I keep adding 3, keep adding 3, keep adding 3, you get to the next numbers. Okay, but if you don't like using this way, you can still use your formula. Our formula was a sub n equals to a sub 1 plus d times n minus 1. So this would be 19 plus, sorry, equal to a sub 1 plus, I know the pattern is 3, and 19 is my second term, so it will be 2 minus 1. And then if you solve for this, 3 times 1 is 3, and then we minus 3 on both sides, we get 16 equals to a sub 1. So both way works, we still get 16 as our answer. Okay. Number 36, find the 10th term. So I already have a second term is 3, seventh term is 11. This is geometric though. Okay, this is one of the harder questions. So if I know my seventh and second term, we're going to be using all of this information to figure out what the ratio is. Okay, so I'm going to say g sub 7 equals to g sub 2 times r to the, how much is 2 to 7? Is 5 numbers away, right? So this new formula, we're going to substitute all the numbers in there. We got 3 times r to the 5th power equals to 11. Divide both sides by 3. We have 11 over 3 equals to r to the 5th power. Multiply both sides, raise it to the 1/5. So this goes away, r equals to 11 over 3 to the 1/5. That's actually the ratio, okay? We're not done yet. We had to find out the 10th term, because they're asking for the 10th term. So g sub 10 equals to, the closest number that we know to 10, g sub 10 is, oops, sorry, these are g sub 7. So g sub 7 times r to the, how far are they from each other? They're 3 numbers away. Okay, and then substitute. We get 11 times our ratio, which is 11 over 3 to the 1/5 to the 3rd power equals to g sub 10. This becomes 3/5. 11 over 3 times 11 is g sub 10. And if you put this in the calculator, you should get 23.9859. Okay, so that's it. Let me just summarize real quick that like our two formula. So if it's arithmetic and geometric, arithmetic formula is a sub n equals to a sub 1 plus d times n minus 1. Geometric is g sub n equals to g sub 1 times r to the n minus 1. Okay, that's it.